We have found more than 5,000 worlds beyond the sun. Almost none of them could hold a life like ours. They are too hot, or too cold, or crushed under the wrong air, or left drifting with no sun at all. The strange part isn't that so many worlds are dead. It's that a living one, so far, is the exception. The best answer anyone has is a simple one. Life like ours needs a narrow, gentle set of conditions. A little warmth, some air that stays put, water that can rest as a liquid without boiling away or freezing hard. Most worlds miss that narrow window and miss it by a long way. Just how rare the ones that don't miss it are, nobody yet knows. That part is still open, and it can stay open tonight. The count of them keeps climbing too. Thousands of worlds are known now, and each new one seems stranger than the last. Some are hot enough to boil metal. Some are colder than anything here could bear. Some have no sun at all and simply drift through the dark. What almost none of them have is the one small, ordinary miracle that makes a world a place to live. So this is not a sad tour and not a frightening one. It is only a long, gentle look at how many ways there are to be a world, and how rare and lucky the living kind turns out to be. This is cosmic drift, calm space science, made for the edge of sleep. If quiet nights like this are your kind of thing, a subscribe helps more of them reach the people who need them. No rush. There's nothing here to stay awake for. If sleep arrives before the third world, the night still did its work. Here is the shape of it. We start close to home, with the worlds our own sun has already lost. Then we drift outward, world by world, to stranger and colder and more wonderful dead ends. And we finish at the one world anyone knows for certain is still awake. There is no test at the end of any of it, and nothing to hold on to. Only a long, calm walk from world to world, in the dark, at the speed of a slow breath. So we begin next door. There is a planet almost exactly the size of Earth. It is close enough that people once called it our twin and dreamed of oceans there. It turned out to be the most hostile place in the whole solar system. Its name is Venus. Venus is nearly Earth's size and nearly Earth's weight. From far away, it looks soft, pale, wrapped in bright, unbroken cloud. For a long time, people looked at that cloud and imagined warm lagoons underneath, or a single worldwide sea. The truth below is harder than any of that hoping. The air on Venus is mostly carbon dioxide, and there is a crushing amount of it. On the surface, the weight of that air presses down like the water, almost a kilometer deep in the ocean. It would press on a visitor, the way the deep sea presses on a submarine. And the bright clouds are not water at all. They are made of sulfuric acid, the kind that stings. Then there is the heat. The surface of Venus sits near 460 degrees on the Celsius scale. That is hotter than a kitchen oven turned as high as it will go. It is hot enough to melt lead into a bright puddle, and it is the same nearly everywhere. Dayside and nightside, poles and equator, noon and midnight alike. Venus keeps no cool corners. The cause is a runaway greenhouse, and it is worth saying gently, because it is the quietest kind of ruin. Long ago, the young sun grew slowly brighter, the way young stars do. Whatever water Venus held began to lift into the sky as vapor. Water vapor holds heat, and the held heat lifted still more vapor, and the thing fed on itself until the seas, if there were seas, had boiled away into the air. What stayed was carbon dioxide, thick and heavy, holding the warmth in under a lid that never lifts. The models suggest Venus may have had mild stretches once, maybe shallow water, for 1 billion years or more. If it did, it lost them. It warmed itself from inside its own air until nothing soft could last. There is a slowness to the way Venus turns, too. It spins backward, against the direction of almost everything else in the family of planets, and it spins so slowly that a single Venus day runs longer than a Venus year. The sun, if it could be seen through the cloud, would rise in the west and cross the sky over nearly 4 Earth months. A day longer than a year is either poetry or a filing error, depending on the mood a person brings to it. Machines have tried to land there. In the 1970s, a run of small Soviet craft, the Venera landers, fell through the cloud and reached the ground. They were built like deep-sea bells, sealed and heavy and brave. The toughest of them lasted about 2 hours before the heat and the pressure closed them down. And 2 hours was long enough to send home a few photographs. In those pictures, the ground lies flat and orange, littered with broken slabs, under a sky the color of a dim ember. Nothing has lasted much longer since. The planet does not keep its guests. Venus has almost no magnetic field to speak of. Its surface looks strangely young, repaved over and over by slow volcanoes. It is a world that stayed geologically busy while turning completely unlivable, which is its own kind of loneliness. Nothing about it is broken. Every rule it follows is a rule that works. It just followed those rules all the way to a place with no room in it for anything alive. For all its cruelty, Venus is the loveliest light in our sky. After the sun and the moon, nothing we see is brighter. It is the evening star that hangs over the sunset, and the morning star that waits at dawn, the same world under both names. People have followed it and wished on it for as long as there have been people to look up. The beauty is real. It is only a beauty best admired from a long way off. The air itself does something no other planet's air does. While the solid world turns with its slow backward crawl, the whole thick atmosphere races around far faster, lapping the globe in only about 4 days. The clouds are caught in a permanent gale that never quite touches the ground, a sky spinning many times faster than the planet beneath it. No one is fully sure how it keeps that up, and because the cloud never breaks, the surface stayed hidden for the whole of human history. It took radar beamed down through the haze from an orbiting craft called Magellan to draw the first real map by feeling through the murk. It found broad volcanic plains, wide enough to cover most of the planet, and long ridges, and one great highland crowned by a peak that stands taller than Everest. A whole landscape, sketched by radio, on a world no ordinary camera will ever see. There is a quiet lesson tucked into Venus, worth setting down gently before moving on. Earth and Venus began as near twins, the same size, near enough, the same rough recipe of rock and metal and air. Two neighboring worlds, formed side by side around the same young sun. And then their two stories split. One kept its water and its mild sky, and slowly became the only living world anyone has ever found. The other lost everything soft to a warmth that fed on itself. It is not a warning tonight. It is only a reminder of how fine the line can be, and how kindly hours happen to fall. So the twin next door keeps turning in its bright acid cloud. It holds its 460 degrees close, day and night the same, refusing, as it always has, to cool down and be reasonable. It is the first dead world, and one of the strangest, and it is only the nearest one. The next world out died the opposite way. Venus smothered under too much air. Mars lost almost all of it, and went cold and thin and quiet. Mars is a small world, about half the width of Earth, the color of old rust. And the rust is a real clue. Not just a color. It is iron in the soil that has slowly reacted with oxygen over ages. So the whole planet has, in a sense, gently gone the way an old nail goes. Today the air is so thin that standing water can't survive on the surface. It would boil and freeze almost at once. The average temperature sits far below freezing, around 60 degrees below zero on the Celsius scale, and a mild afternoon near the equator can still fall to 80 below by night. But Mars was not always like this. The clearest thing the rovers and orbiters have found is that water once ran here and ran freely. There are dry riverbeds with braided channels. There are deltas where a river once spread into a standing lake and dropped its silt in fans, the same shape rivers leave on Earth. There are minerals in the rock that only form in liquid water, sitting there in plain sight. Billions of years ago, Mars had rivers, lakes, maybe a shallow sea across its northern half, under a thicker sky and a warmer climate. So the question is where all of that went. The best answer points to several losses that worked together. Mars is small, and a small world cools faster from the inside. Its churning metal core slowed, and its global magnetic field faded. Its lower gravity also made atmospheric gases easier to lose. With a thin upper atmosphere exposed to solar radiation and the solar wind, particles have been escaping into space, one small loss at a time, for billions of years. We did not have to guess at that last part. A NASA orbiter named Maven was sent to Mars in 2013 for exactly this question. Over more than 11 years, it watched the Martian atmosphere continuing to escape, faster when the sun was active and slower when the sun was calm. Its mission ended in 2026, but the data it returned still show how solar activity drives atmospheric loss. The planet is still, very gradually, losing what little atmosphere it has left. The bleeding never fully stopped. It only slowed. What's left is a world of thin pink air and enormous patient landscape. Mars has the tallest volcano known on any planet, a mountain called Olympus Mons, wide enough to cover a whole country and nearly 3 times the height of Everest. So broad and gentle a climber standing on it might not know it was a mountain at all. It has a canyon system that would stretch across the entire United States. It has ice, real water ice, frozen at both poles and buried under wide plains. Enough that a future visitor would not go thirsty, only cold. And it has 2 tiny lumpen moons, Phobos and Deimos, that look more like captured asteroids than proper moons, one of them slowly falling closer over millions of years. There are machines on Mars right now, still working, rolling a few careful meters a day across the rust and drilling small holes to read the past in the rock. They are looking, patiently, for any sign that something once lived in that old water, before the air thinned out and the cold came down to stay. Nothing has been found yet. Not finding it isn't the same as it never being there, and the search is gentle and unhurried, the way the best searches are. Mars keeps other records too. It holds a canyon so long that, laid across the Earth, it would stretch nearly from coast to coast, a great split in the crust called Valles Marineris, deep enough in places to swallow the tallest mountains whole. And every so often the whole planet vanishes from view. Dust storms rise and spread and join together until they wrap the entire world in a rust-colored haze that can last for weeks. From orbit, the ground simply disappears, then slowly, grain by grain, settles back into place. Its 2 little moons keep it company in odd ways. The inner one, Phobos, races so close and so fast that it rises in the west and sets in the east and crosses the whole sky twice in a single Martian day. It is creeping slowly inward too, and far in the future, it will likely break apart into a thin ring around the planet. The light on Mars runs backward from ours as well. The dusty daytime sky glows a soft butterscotch, and only near the sun, at sunset, does it cool to a gentle blue. On Mars, the blue hour is the end of the day, not the middle of it. The poles breathe with the seasons. Their caps are partly frozen carbon dioxide, dry ice, that grows in the winter and shrinks in the summer as it turns straight from solid to vapor and back. Around and beneath them lies real water ice, and a great deal of it. If it ever warmed and ran, the old rivers would have something to carry again. For now it stays locked and pale at the top and bottom of the world, waiting, the way everything on Mars seems to be waiting. Mars is not a frightening place. It is a calm, rust-red, half-sized world, colder than the coldest winter, holding its old rivers as dry scars and its water as buried ice. Whatever it was on the way to becoming, the air blew away before it could arrive. And so it waits, quietly, keeping the shape of its rivers long after the water is gone. Nearer the sun than any planet is a small gray world with no air to soften a thing. Mercury is barely wider than the moon. It has almost no atmosphere, only the faintest trace, far too thin to hold warmth or carry it around. And with nothing to move the heat, the little planet keeps its two extremes right beside each other. On the day side, under a sun that looms enormous in a black sky, the ground bakes to about 430 degrees on the Celsius scale. That is hot enough to soften metal. On the night side, the same ground falls to nearly 200 degrees below zero. Between noon and midnight, then, Mercury swings by some 600 degrees, the widest range of any planet we know. It is a furnace and an ice cellar wearing a single skin. It turns slowly, and it turns oddly. For every 2 trips around the sun, it spins exactly 3 times. Because of that neat arrangement, 1 full day and night on Mercury takes about 176 Earth days. The sun crawls across the black sky, and from a few places on the surface, it can even seem to slow, stop, and slide backward a little before moving on again. A traveler there could, in the right spot, watch the sun rise part way, sink back down, and rise a second time. It is a long, slow morning, followed by a long, deep night. In that sky, the sun would look 2 to 3 times as wide as it does from here, and far fiercer. Mercury has no moons and no rings. Nothing at all keeps it company. It even trails a faint, thin tail of sodium, blown back by the sunlight like the tail of a shy comet, though no eye could ever see it. Under the gray dust, most of Mercury is metal. Its core is enormous, filling the great majority of the planet, a ball of iron wrapped in only a thin coat of rock. More than anything, Mercury is a heart with a little stone around it. As that iron core cooled across the ages, it shrank, and the whole planet shrank along with it, wrinkling the way fruit wrinkles when it is left too long in the bowl. Those wrinkles are still there, long cliffs and ridges running for hundreds of kilometers, some tall enough to throw a real shadow at dawn. There is one enormous scar as well, a crater called the Caloris Basin, wide enough to swallow a small country. Whatever struck to make it hit so hard that the shock ran clean through the planet and jumbled the ground on the far side. Mercury has carried that dent, calmly, for billions of years. And here is the gentle surprise. On a planet close enough to the sun to melt lead by day, there is ice. At the north and south poles, some crater floors never once catch the light. The sun sits so low there that the deepest floors stay in permanent shadow, and in that shadow, the cold is total. A spacecraft called Messenger, which circled Mercury for 4 years, found the fingerprints of water ice tucked into those dark craters. Ice, a stone's throw from the hottest daylight anywhere near us, kept safe only by never once being touched by the sun. Nothing lives on Mercury, and nothing was ever likely to. It has no air to breathe, no water on its surface, no shelter from the harder light. It is a world of long shadows and longer days, of a metal heart cooling slowly inside a wrinkled shell. There is a strange calendar to it as well, because Mercury swings around the sun in only about 88 days. 4 of its years pass inside a single one of ours. Someone keeping birthdays there would gather 4 every Earth year, while barely 2 of its long days and nights went by. and there is no soft light to any of it. With almost no air, Mercury has no real dawn and no dusk. The sky stays black, the stars stay out even at noon, and the enormous sun simply hangs in that black, fierce and silent, throwing shadows with hard edges, because nothing is there to scatter the light. Day meets night along a sharp line, with no gentle blur between them. The little machine on its way there now, taking the slow road with the help of gravity, is called Bepi Colombo. When it settles into orbit, it will map the wrinkled cliffs and the shadowed ice, and take a closer look at the odd bright hollows that freckle the surface, shallow dents that look, from above, as though something once bubbled quietly up out of the ground and drifted away. There is something restful about Mercury, once the numbers settle. It asks for nothing. It keeps its fire and its ice in careful, separate corners, and it has done so without complaint for far longer than there have been eyes to notice. The little gray world turns 3 times for every 2 laps, patient as an old clock, and the ice waits in the dark, where the light has simply never had a way to reach. One dead world sits close enough to see from a bedroom window tonight. It has no air, no weather, no sound. It is the only other world any human being has ever stood on. It is the moon. The moon is a still place, and still is almost too soft a word for it. There is no wind there, because there is no air to move. There is no rain, no snow, no running water, no weather of any kind. The sky above the gray plains stays black even at high noon, because there is no air to catch the sunlight and turn it blue. A person standing there would hear nothing at all, not even their own footsteps, only whatever sound traveled up through the suit. It is the quietest ground within reach. Its days are as slow as its silence. The moon turns once as it circles us, so it takes about 2 weeks of daylight, then 2 weeks of night, to turn all the way around. In the long day, the surface climbs above 100 degrees on the Celsius scale. In the long night, it falls to more than 130 below. And because the moon always keeps one face turned toward Earth, there is a whole far side that no one on Earth had ever seen until spacecraft finally went around and looked. The moon is nearly dead inside, as well as out. Deep down, it still gives the faintest tremors, small, slow moonquakes. But the heat and the churning that shape a living world have mostly gone quiet. It holds a little water too, frozen in the same kind of permanently shadowed craters that hide ice on Mercury, waiting near the poles where the sun never clears the crater rim. Here is the thing that stays with people, though. Because there is no wind and no water on the moon, nothing there gets worn away. When 12 people walked on it, between 1969 and the end of 1972, they left boot prints in the gray dust. Those boot prints are still there. So are the wheel tracks, and the flags, and the lonely lower halves of the landing craft. Nothing has blown them away, because nothing blows. Nothing has washed them out, because nothing flows. They are slowly, slowly softened by the faint rain of micrometeorites that peppers the surface over ages, but that erasing is measured in millions of years. A footprint on the moon will likely outlast every cathedral on Earth. The moon is quietly leaving too, though there is no hurry in it. Each year it drifts a little farther from Earth. About the width a fingernail grows in that same year. Long ago, it hung much larger and closer in the sky. Far in the future, it will hang a little smaller. Tonight, it is right where it has been all your life, holding its old prince in the dark. And there is one more soft fact about it. The moon is very likely a piece of the early Earth, splashed off in a great collision when the world was young, then gathered into a ball of its own. So the nearest dead world is not a stranger. It is something closer to a sibling, made of the same early stuff that simply never became a place where anything could live. The moon does one quiet thing for the living world beside it as well. Its steady pull raises the tides that breathe in and out along every shore. And across the long ages, it has held the tilt of the earth nearly steady, so the seasons stay mild and familiar instead of lurching wildly about. In a plain sense, the dead world helps keep the living one livable. It is an old partnership, far older than anything that walks around down here. The gray markings on it are easy to find on a clear night, and they have their own gentle history. The dark patches are old seas, though never of water. Long ago, great floods of lava welled up and froze into smooth, dark plains. And those are the shapes people have called the man in the moon, or the hare, for thousands of years. The far side, the one that never turns our way, turned out to be a different sort of place, rougher and paler, and almost without those dark plains. It kept its face hidden from everyone until spacecraft finally rounded it and looked. 12 people stood there and looked back at the Earth, small and blue and alone in the black, and then they came home. No one has been back since, though there are plans, gentle and serious, to go again. Until then, the moon keeps the prints exactly as they were left, in a silence with nothing in it to disturb them. Of all the dead worlds, it is the one that has felt a human hand, and it is holding on to the evidence, patiently, in the quiet. Before the tour leaves the sun's family for good, there is one more world here, worth a long, slow look. It is a moon, not a planet, and it may be the strangest quiet place in the whole solar system, because at a glance, it looks almost like home. Its name is Titan, and it circles Saturn, far out where the sun is small. Titan is larger than the planet Mercury, and alone among all the hundreds of moons, it wears a real atmosphere, thick and golden, so hazy that for a long time no one could see its ground at all. The air is mostly nitrogen, like the air in this room, and it presses down only a little heavier than the air here tonight. A person standing on Titan would not be crushed and would not need a pressure suit, only a very warm coat and something to breathe. The cold is the whole trouble, because Titan is bitterly cold, nearly 200 degrees below zero on the Celsius scale. That is far too cold for liquid water. The water on Titan is frozen as hard as bedrock and makes up much of the ground. But at that temperature, something else flows in its place. Methane. The same stuff that hisses from a kitchen stove is cold enough, out there, to pool and run as a liquid. And so Titan has the one thing nearly every other dead world on this tour was missing. It has rivers, it has rain, it has lakes, and even seas lying dark and flat near its northern pole, wide enough to sail across if the cold and the fuel did not undo the boat. The two largest even have names now, Kraken and Ligeia, seas of methane and ethane, bigger than any lake on Earth. The rain that fills them is not water. It is a slow methane drizzle, falling through the thick orange air, gathering into streams, carving little valleys, running down to the seas. There is weather on Titan, real weather. Clouds gather and pass. Storms come. The lakes shrink and swell as the long seasons turn. For a single year on Titan is nearly 30 of ours. Near the equator, there are wide fields of dunes, hundreds of them, made not of pale sand, but of dark, soft grains that settle out of the hazy sky. The wind heaps them into long ridges, the very shapes a desert makes on Earth, only darker and colder, and lit by a sun hundreds of times fainter than ours. That golden haze is doing quiet chemistry as well. High in the air, sunlight works on the methane and the nitrogen and builds them into heavier, more tangled molecules. The sooty orange stuff that drifts down and darkens the dunes. They are the raw ingredients that life is built from, here, mixed and falling like a slow snow. The ingredients on Titan without the life. As far as anyone can tell, nothing there has ever taken the next step. We have visited, once and briefly. A small probe called Huygens rode a larger craft all the way to Saturn, then let go and drifted down through the haze on a parachute in 2005. It was the most distant landing anyone has ever made. On the way down, it photographed what looked, almost achingly, like river channels running to a shore. It settled softly onto a floodplain scattered with rounded pebbles, stones smoothed as though by running liquid. Among the hundreds of images it returned was one view of the pale orange ground. It continued transmitting after landing until its communication window with Cassini ended. A single afternoon, on a shore 1 billion kilometers away. Far beneath all of this, deep under the icy crust, Titan very likely hides a second sea, an ocean of ordinary water, kept liquid by the moon's own inner warmth, dark and buried and still. So it is a world with two kinds of sea, cold rivers of fuel on the surface, under an orange sky, and a hidden water ocean far below that no one will lay eyes on for a very long time. For all of it, Titan is almost certainly a dead world. It is too cold, by a wide margin, for anything like the life we know. But it is the one dead world that behaves like a living one. It rains and pools and dries and rains again. Its shores are moved by slow tides. Its dunes are built by the wind. Its sky clouds over and clears. There is a plan to go back, with a machine that can fly, drifting from dune to dune in that thick, slow air. Until then, Titan keeps its calm, alien weather to itself. The methane rain falls on the methane seas. The dark dunes shift, grain by grain, and the whole gentle, frozen, earth-shaped world turns quietly around Saturn, having its seasons and keeping its shorelines, with no one there at all to watch the tide come in. Now the tour leaves the sun's own family behind. Everything from here is far off, light years away, around other stars. And the first of those far worlds is a place where models suggest rock may fall from the sky. Astronomers have found a whole class of these, sitting so close to their stars that the word planet almost feels wrong for them. One of the clearest is a world catalogued as K2-141b. It circles its star not in a year, not in a month, but in about 7 hours. It is so near the fire that it has almost certainly been locked in place. One face held toward the star for all time, the other turned forever out to space. On that sunward face, the rock itself has melted. There is an ocean there, but not an ocean of water. It is an ocean of molten stone, glowing, hundreds of kilometers wide, with a surface temperature somewhere near 3,000 degrees on the Celsius scale. At that heat, rock does not just melt, it steams. The magma sea gives off a thin haze of rock vapor, an atmosphere made of the very things pavements are made of, sodium and silicon, hanging in the air as gas. Then the modeled weather begins, and the weather is the strangest part. Simulations suggest winds could carry rock vapor away from the molten sea and toward the colder night side. Out there, in the dark, the vapor may cool and condense. Mineral material could fall back toward the surface and return, through slow molten flows, toward the glowing sea to be vaporized again. It would be a water cycle, with the water swapped out for stone. In that model, the forecast is rock, with a strong chance of more rock, tomorrow and every day after. There are others like it. A world called 55 Cancri A, about twice the width of Earth, and some 40 light-years off, may be another lava world, and telescopes have lately caught signs of a real atmosphere clinging to it, fed from its own molten interior. Each of these places is a small hot lantern of a planet, close in, tide-locked, half-glowing and half-dark. Nothing about these worlds is subtle. They are too near their stars, too hot on one side, too cold on the other, held in place so firmly that they cannot even turn to share the warmth. They are what a rocky world becomes when it forms, or drifts, too close to the fire, not broken, just placed somewhere with no mercy in it. Worlds like this are found by patience and shadow. When a planet crosses in front of its star, it blocks a tiny sliver of the light, and from the depth and rhythm of that dimming, astronomers can work out the world and its tight little orbit. The first rocky planet ever found this way, catalogued as Korot 7b, turned out to be one of these lava worlds, close in and part molten. A whole handful have joined the list since. They are the planets that formed, or drifted, right up against the fire, and never got the chance to cool. The strangest thing about their air is that it may come and go with the heat. In the models, a thin atmosphere of vaporized rock forms over the blazing day side, while some of that material may condense toward cooler regions. The weather does not merely happen in the air. The weather is made from the surface itself, lifting from the ground and settling back down again. One of these worlds, the one called 55 Cancri E, was once even guessed to be a planet rich in diamond, before closer looks made the truth more ordinary and stranger at the same time. And yet, from a very long way off, a lava world is a lovely thing to picture. A small dark sphere, one edge lit to a deep ember orange, a thread of glowing rivers running down toward a sea that shines like a coal. It turns nowhere because it cannot turn. It just holds its molten face to its star, while mottled currents carry vapor toward the dark side, and mineral material settles back toward the ground, keeping a weather no one will ever stand in. Farther along, there is a world painted almost exactly the blue of Earth seen from space. From a distance, it might fool a tired eye. Up close, it is one of the most hostile places anyone has ever measured. It is a giant, larger than Jupiter, known by its catalog name, HD 189733b. It lies about 63 light-years away, and it huddles so close to its star that its year lasts only 2 and a bit Earth days. When telescopes manage to tease out its color, a deep cobalt blue, there was a brief, lovely moment where it sounded like a water world. It is not. On this planet, the blue does not come from oceans. It comes from the air. The atmosphere of the blue world is thought to contain tiny silicate particles, the stuff of glass and sand. Those particles can scatter blue light back to space, helping give the planet its ocean color. And the air up there is furnace hot, well over 1,000 degrees. Atmospheric models suggest that silicates may condense into grains and be carried through the sky. In the most vivid version of the model, the result is something like a rain of glass. Then the wind gets hold of it. Estimated winds on the blue world may reach something like 2 kilometers every second. That is close to 7 times as fast as a passing jetliner, and far faster than any storm Earth could dream up. If silicate grains condense, as the models suggest, they would not fall straight down. They could be swept almost sideways through the sky, carried faster than sound. The prettiest blue in all the catalogs, and absolutely nowhere to stand beneath it. The blue world is a gas giant, so there is no true surface anyway, no shore to walk, only deeper and thicker layers of screaming air pressing down into heat and dark. It is losing some of its outer atmosphere to the star as well, a faint streaming away at the top, the way all these close-in giants seem to leak. It formed, most likely, farther out where things were calmer, then drifted inward to this scorching orbit, and settled into being beautiful and impossible at the same time. There is a lesson tucked in the blue world, and it is a soft one, worth setting down without alarm. Color, out in the galaxy, is not a promise. The blue that means water and sky and shallows here can mean elsewhere an atmosphere shaped by haze and possible silicate grains moving at extreme speed. A world can wear the exact shade of home and be nothing like it. The eye wants to trust that blue. The measurements ask it, kindly, to wait. The color was not a guess. Astronomers measured it by watching the planet's light, as the world slipped behind its star and came out again. When the planet hid, a faint blue tint drained from the combined light, and when it returned, the blue came back with it. That is how they knew the planet itself was blue. The first time anyone had ever pinned down the true color of a world around another star. It sits in a small northern group of stars, among points of light a person could pick out on a clear night, though the planet itself is far too faint and far to ever notice by eye. Its star is not gentle with it either. The world orbits so close that the star's harder light is slowly boiling the top of its atmosphere away, so the planet trails a faint, warm exhale of gas behind it as it goes. It keeps one face turned toward the star, like so many of these close-in worlds. So one side bakes in endless day, while the other turns to a cooler night, and fierce winds pour from the hot side to the cold. Somewhere in that racing air, silicate grains may form and be swept sideways through the half-dark. So the blue world turns its bright face through space, with possible silicate grains swept sideways in its high, hot winds, looking for all the galaxy like a drop of ocean, while hiding no blue ocean beneath its clouds. It is lovely, and it is lethal, and it is very, very far away. Nothing about it needs to trouble a quiet room tonight. There is a world out past the blue one that is hotter than some stars. It is worth pausing on, because it sits right at the edge of what the word planet can even mean. It is a giant, a great ball of gas, and it circles a big, brilliant blue-white star at a hugging distance. That kind of star burns far hotter than our sun, and the planet sits right up against its fire. The day side of this world glows at something like 4,000 degrees on the Celsius scale. That is hotter than many smaller stars ever manage to be. The planet does not merely reflect its star's light. It is hot enough to pour out a fierce light of its own, glowing like an ember pulled from a furnace. At that heat, the ordinary rules of a sky break down. Molecules cannot hold together. The gases that would normally pair up into neat little pieces are torn clean apart on the day side, ripped down into their bare, single atoms by the sheer heat. It is an atmosphere that has been pulled to pieces. Then the winds carry that shredded air around to the night side, where it is a touch cooler, and something gentle happens in all the violence. The atoms find each other again. They join back into molecules, quietly, in the dark, only to be swept back to the day side and torn apart once more. The whole world is caught in an endless loop of coming undone and knitting back together, over and over, forever. The star is not finished with it either. Its harder light is boiling the planet's outer air away, so the world trails a faint tail behind it as it goes, like a comet the size of a giant planet. It is slowly being unmade from the outside in, though it holds enough gas that the unmaking will take an age. Nothing about this world is survivable, or ever could be. It is a planet turned into a furnace, glowing in the dark, streaming a tail, tearing up its own air by day and mending it by night. And yet, told from a safe and enormous distance, there is a strange calm to it. It is only doing what a thing that close to a fire must do. It glows, and it streams, and it turns. Held in a bright grip, it will never slip. Far enough away that its heat will never so much as warm this room. Some of these close-in worlds never see their star move at all. To understand them, it helps to remember the moon, which always keeps one face turned toward Earth. The same thing happens to many planets that orbit near their stars. The star's pull grips them and slows their spin until, at last, one side is held toward the light forever, and the other is turned away into endless night. A world like that has no sunrise and no sunset, not because the day is long, but because the day never ends and never begins. On the day side, the star hangs fixed in the sky. It sits in the same spot at what would be morning, noon, and evening, never climbing, never sinking. It simply stays. On the night side, there is no star in the sky at all, only the dark and the cold, held without relief for the whole life of the planet. Between those two halves runs the strangest and softest place on such a world. It is a ring, a great circle wrapping all the way around, where the star sits forever on the horizon, a band of permanent dusk. Stand there, and it would be eternal sunset in one direction and eternal dawn in the other, a thin sliver of gentle light, dividing a wall of fire from a field of ice. The light would never change. The shadows would never move. A single long evening, stretched around an entire world, holding still. The two faces live utterly different lives. The dayside bakes under its motionless star, often hot enough to melt or to boil away any air and water. The night side freezes so deep that gases can settle out and lie frozen on the ground, and between them, the air tries, endlessly, to fix the imbalance. Winds pour from the hot side toward the cold side, high and fast, forever carrying warmth toward a darkness that never fills up. The weather on a locked world is one long attempt to even out a heat that will never be even. Most of these worlds are surely dead. The extremes are simply too much. But there is a soft idea that scientists genuinely turn over, and it is worth telling for the pleasure of the thought, no more than that. On some gentler locked world, around a cooler and calmer star, the day side might be too hot and the night side too cold, while that thin ring of eternal twilight stays mild. A single livable band of endless evening, wrapped around a world that is scorched on one side and frozen on the other. Nobody knows if such a place exists. It is allowed by what we understand, and it is not ruled out, and that is all anyone can honestly say tonight. Most of the worlds visited tonight are held this way. The lava worlds are locked. The blue giant with its possible silicate storms is locked. It happens whenever a world sits close enough to its star, for long enough, because the star's pull grips the near side a touch harder than the far side, and over the ages, that uneven grip slows the spin until the world stops keeping time with its own day and starts keeping time with its orbit instead. Even our own moon has done it, in its gentle way, which is why it always turns the same patient face toward the earth. There is one more picture worth holding, softly, for the pleasure of it. Imagine such a world with a little water on it. The day side, under its unmoving star, might keep one warm sea, a round eye of open water staring forever at the light. The night side would freeze to a cap of ice. From far enough away, the whole world would look like a great eyeball, a bright wet circle rimmed in white, turned always toward its sun. Nobody has found one quite like that. It is only a shape the mathematics allows, and a calm thing to picture on the way towards sleep. There is something restful in the picture, all the same. A world where the light holds perfectly still, where the sun is a lamp that someone set down on the horizon and never picked up again. Most of these are dead ends, too harsh on both faces for anything to hold on. But the image they leave is a calm one, of a long, unmoving dusk, turning slowly through the dark, keeping the same soft light on the same still line of ground for as long as the star burns. Not every world has a single sun to circle. Some go around two. There are worlds out there that orbit a pair of stars at once, two suns bound together, turning around each other, with the planets swinging in a wide ring around them both. The first one found this way came as a real surprise, because for a long time it was not clear such a world could even hold a steady path around two moving stars without being flung out. But there it was, a planet circling a close pair, keeping its orbit calmly, year after year. Stand on a world like that, if it had any ground to stand on, and the sky would run on a stranger clock than ours. There would be two suns in it, not one. Some days they would rise close together, and the world would have a single bright morning. On others they would part, and rise hours apart, so that one sun came up, and then the other, and the day brightened in two gentle steps. Shadows would come in pairs, one for each sun, crossing and sliding past each other as the two stars moved. And the sun sets. On a world with two suns, the evening can come twice. One sun slips below the horizon, and the light softens, and then the second follows it down a while later, and only then does the true dark arrive. Two sunsets, one after the other, ending a single day. The worlds found circling two stars so far are mostly cool giants, balls of gas well out from their pair of suns, almost certainly lifeless. The famous first one is a chilly, Saturn-like gas giant, far too cold and with no solid surface suitable for life. But it settled an old question. Worlds can form and hold their orbits around two stars at once. Many more of these double sun worlds have turned up since. It is a picture worth keeping for the quiet. A cold, dead giant, turning far out in the dark, with two small suns rising over it and setting over it, casting their doubled shadows across a world where no one has ever stood to watch the two of them go down together. One of these close giants is not only dying, it is being slowly eaten, and we have watched it happen. The world is another hot giant, larger than Jupiter, and it orbits its star at a shocking, hugging distance. Its whole year, One full trip around takes only about a single Earth day. Nothing that large has any business sitting that close. And the star, in return, is pulling the planet apart with sheer gravity. The world is no longer round. It has been stretched into the shape of an egg, drawn out along the line toward its star, its near side hauled up into a bulge that reaches toward the fire. From that stretched bulge, the planet is leaking. The star's heat and pull are lifting the outer layers of its atmosphere away, drawing a faint stream of gas off the top of the world and pulling it slowly inward, the way a warm drink gives off a thread of steam. The planet is spilling itself into its star, a little at a time, and it cannot stop. There is more. Careful timing of the world's orbit, watched patiently over years, has shown that the orbit itself is shrinking. The planet is not holding steady. It is spiraling inward, creeping closer to the star with every pass, on a slow inward curve that has only one ending. In time, this world will be pulled all the way down and swallowed whole. Now, this is the point in the night to slow down and say the plain thing gently, because it is a death, and a death deserves a moment. Yes, the planet is doomed. Yes, it will one day fall into its star and be gone. But the timing is the mercy here. The best measurements say the fall will take about 3 million years still to finish. 3 million years is longer than there have been human beings on Earth, many times over. It is so long that calling the planet doomed feels almost unfair. Set down beside a human night, it is not falling at all. It is simply turning out there, whole and bright, in no hurry to end. So set it down that way. The egg-shaped world circles its star at tremendous speed, stretched and streaming a little from its bright bulge, unhurried, with millions of years of turning still ahead of it. It is the clearest case anyone has found of a star and its planet locked in a slow goodbye. And even that goodbye is patient, so patient that from a human distance, it looks exactly like permanence. This world was found in 2008, and it lies about 870 light years off. And the light showing it to us tonight set out long before anyone alive was born. It is also one of the darkest planets ever measured. It drinks in nearly all the light that falls on it and gives almost none back, so that up close it would look less like a world than like a warm black absence, ringed by the glare of the star it is slipping toward. It is not the only one of its kind, only the clearest. A few other giant worlds have been caught on the same slow inward spiral, hugging their stars and quietly running out of orbit. When each is finally taken in, its star will brighten a little for a time, wearing the last of the planet as a brief new warmth. It is a strange sort of ending, to become, for a moment, part of the light of the very thing that swallowed you. But that too is far away, and slow, and nothing to carry into a quiet room. It will be a very long time before anything changes out there. The world is still round enough to shine, still whole, still keeping its impossible little year. There is nothing in its slow fall that belongs in a quiet room at bedtime. It is a far-off, gradual, almost gentle ending, 3 million years wide, and tonight, as on every night for ages to come, the planet is simply there, turning in its bright, close orbit, held and streaming and not yet gone. There is a world where the leading interpretation suggests iron may condense and fall on its cooler side. It sounds like a tall tale, but the measurements are real, and the picture they support is oddly calm from far enough away. It is another hot giant, tide-locked to its star, one face held always to the fire. On that day side, the heat climbs to around 2,400 degrees on the Celsius scale. That is hot enough to boil metal. The iron in the planet's rock and air does not stay solid, and does not even stay liquid. On the blazing day side, it turns to vapor, a haze of iron gas rising into the sky. Then the winds carry that iron vapor toward the night side, cooler now, though only by the standards of a furnace. The leading interpretation is that some of the iron may condense as it reaches cooler regions. It may gather into droplets and fall deeper into the atmosphere. On the night side of this world, iron may fall from a dark sky, night after night after night. Astronomers inferred this by catching an uneven fingerprint of iron in the planet's light across different sides of the atmosphere. Condensation on the cooler side is one leading explanation, though the detailed weather remains under study. It is a weather report from 600 light-years away, with iron in the air and a forecast still being refined. Nothing could stand in that atmosphere, of course, and there is no ground beneath it to stand on, but set it down gently, from here. It is only a very hot world, doing what a very hot world must. Iron remains in vapor on the hotter side, and may condense toward the cooler side, while the planet turns its bright, streaming face through space, keeping a weather no eye will ever see, a long way off and no trouble to anyone. And there is one last small world worth a quiet word, because it is slowly disappearing. It is a little rocky planet, not much larger than our own, but it orbits its star so closely and so hot that its surface has begun to boil away. The rock itself is turning to vapor, lifting off the day side as a thin mineral haze, and streaming away behind the planet into a long, faint tail. From a distance, the little world looks almost like a comet, a small dark stone trailing a plume of its own dust across the sky. It was noticed because its shadow kept changing. When a planet crosses its star, it usually dims the light by the same neat amount each time. This one did not. Its dimming flickered and shifted, deeper some passes and shallower others, because what crosses the star is not just a solid world, but a ragged, changing cloud of dust blowing off it. The planet is coming apart, a little more each orbit, shedding something like a mountain's worth of itself into space now and then. In the far future, this world will simply be gone. It is dissolving into its own tail, grain by grain, and one day the last of it will blow away, and there will be nothing left where a planet used to be. But even that ending is slow, spread over millions of years, far too gradual to watch. For now, it is still there, a small stone crumbling quietly at the edge of its star's fire, trailing its dust like a long gray scarf. It is the most delicate ending on the whole tour. Not a crash, not a swallowing, only a slow letting go. A world breathing itself out into the dark, so gently that from any distance at all, it looks like nothing is happening and everything is perfectly still. Here is a small, strange fact that deserves its own quiet moment. The very first worlds anyone ever found beyond our sun are circling a dead star. The graveyard came before the garden. Before we had seen a single planet around a living, sun-like star, we had found 3 worlds orbiting a corpse. They were discovered in the early part of 1992 by 2 astronomers reading the signals from a place in the constellation Virgo, about 2,300 light-years away. What sits at the center of that system is not a warm star like ours. It is a pulsar. A pulsar is the leftover core of a star that already died, long ago in a great collapse. It is barely wider than a city, but it holds more mass than the sun, packed so tightly that a thimble of it would outweigh a mountain, and it spins fast, hundreds of times every second, sweeping beams of radiation around like the lamp of a lighthouse turned up beyond all reason. That spinning is the reason the planets were found at all. A pulsar's beam sweeps past us with astonishing regularity, tick after tick after tick, steadier than most clocks ever built. When something orbits the pulsar, its gentle pull tugs the dead star a hair this way and a hair that way, and those tiny shifts make the ticks arrive a moment early, then a moment late. By reading that faint rhythm in the timing, the astronomers realized there had to be worlds out there pulling on the corpse. 3 of them, as it turned out. 2 about 4 times the weight of Earth, and a small inner one no heavier than our moon. They were later given names out of old stories about the restless dead. The little inner world is Draugr, an Old Norse word for a body that will not stay in its grave. The other 2 are Poltergeist and Phobitor, one a noisy, haunting spirit, the other a bringer of nightmares. It is grim naming, but it fits. These are worlds bathed, day and forever, in the pulsar's hard radiation, swept over and over by a beam that would sterilize anything. There is no chance of life on them, and there never was. And yet the wonder is that they exist at all. When the star died in the collapse that made the pulsar, its old planets, if it had any, were most likely destroyed. So these 3 worlds are probably second generation, gathered together after the disaster, from the wreckage the dying star left behind. New worlds, built from the ashes of an old star's ending, circling the ember it became. The first planets we ever found were not just dead. They were worlds made out of a death and going around one. A pulsar is what a large star can leave behind when it dies. The star's core falls in on itself in an instant and packs down into a ball only a city wide, spinning faster as it shrinks, the way a skater spins up by pulling in their arms. What is left ticks with almost unbelievable steadiness, and that is exactly why the planets could be felt at all, in the faint wobble of its beat. These three worlds were found a full 3 years before anyone caught sight of a planet circling a normal, living star. The first solid proof that other worlds existed came, of all places, from a corpse keeping perfect time. The odd, storybook names came later, chosen by public vote to suit the eerie place. Draugr, said Draugr. Poltergeist. Phobitor, said Phobitor. A visitor on any of them, if such a thing could be survived, would see no warm sun at all, only a small, fierce point flicking its beams past hundreds of times a second, and a sky scoured of any softness by radiation. Nothing could live there. And yet the three worlds hold their orbits, faithfully, around the thing that ended whatever came before them. There is something almost tender in it, once the grimness is set down. For all of human history, people wondered whether there were other worlds out there beyond the sun. And when the answer finally came, in the last handful of decades, it came from the quietest, deadest corner imaginable, a spinning cinder in Virgo with 3 impossible worlds keeping it company. The garden would come later. The graveyard answered first, ticking softly, 2,300 years of light away. The first worlds we ever found circled a dead star. But the first one found around a living, ordinary star like the sun came a few years later, and it opened a door that has never closed since. It was found in 1995 by 2 astronomers watching a sun-like star gently wobble. The wobble was small, but it was regular. A faint tug that could only mean a world was going around, pulling its star this way and that. The star sits about 50 light-years off, in the constellation Pegasus. The planet around it turned out to be a giant, close in size to Jupiter. But it was not where a giant was supposed to be. Everyone had expected big planets to sit far out from their stars, cold and slow, the way Jupiter and Saturn sit far from our sun. This one hugged its star instead, whipping all the way around in only about 4 days. A giant world, right up against the fire, finishing a whole year in less than a week. It made no sense by the old rules. So the old rules changed. The planet itself is a hot, puffed-up ball of gas, far too warm for any kind of life, another dead world in a long line of them. But it was the one that started the flood. Once astronomers knew to look for these close-in giants and knew the trick of the wobble, the discoveries began to pour in. 1 world, then a dozen, then hundreds, then thousands. Every planet on this whole tour, every lava world and glass rain giant and sunless wanderer was found through the door that this single hot giant pushed open. 2 of the astronomers who did it were given a Nobel Prize for it, decades later. Not bad, for noticing a star lean, just slightly, toward a world no one could see. And the little hot giant that changed everything keeps right on turning, unbothered by its own importance, finishing its 4-day year, again and again, 50 years of light away. Some dead worlds are almost as old as time itself. There is one in particular that has been dead for very nearly the whole life of the universe. It is the oldest planet anyone has ever found. It sits far out in a dense, ancient crowd of stars, a great ball of them called a globular cluster. well above the flat plate of our galaxy. And it is old past easy imagining, something like 12 to 13 billion years old. It came together when the universe itself was still young, not long after the very first stars had lit. It is a gas giant, a couple of times the heft of Jupiter, and it has been turning quietly in the dark since long before there was an Earth, or a sun, or a single grain of the ground under this house. Its home is a strange one, even by the standards of this tour. The planet does not circle one dead star. It circles two, a pulsar and a white dwarf, two cinders wheeling around each other, keeping their long, cold company. And around that pair, the ancient world swings on a wide, slow path, as it has for almost the whole of cosmic history. Nothing lives there, and nothing ever could have. Not around two dead stars, not in that hard and ancient light. But there is something steadying in the thought of it, all the same. This one world has been out there, patient and unbothered, through very nearly everything. Through the slow building of the galaxies, through the birth and death of uncountable stars, through the whole long chain of chance that led, at last, on one small warm planet, to someone lying down to sleep. All that time, it has only turned, old and cold and perfectly calm in its crowd of ancient suns. It was here near the beginning. It will very likely still be here near the end, and it has never once needed anything at all to happen. When a star like our sun finally dies, it does not always leave its planets in peace. Sometimes it grinds them up and wears the dust. Most stars, our own included, end in a gentler way than the pulsar's violent collapse. A sun-like star swells near the end into a vast, cool red giant, sheds its outer layers into space in soft glowing shells, and settles down at last into a small, hot, quiet core called a white dwarf. A white dwarf is the true ember of a dead star. It is about the size of the Earth, but it still holds close to the mass of the sun, so its material is crushed to a staggering density. A single sugar cube of white dwarf stuff would weigh as much as a car, maybe far more. It makes no new light of its own. It just sits there, glowing from leftover heat, cooling over billions of years toward the dark. For a long time, these dead stars were expected to be chemically simple. Any heavy material should sink quickly out of sight into a white dwarf, leaving a clean, plain surface of the lightest gases. But when astronomers looked closely, a great many white dwarfs turned out to be, in the odd technical word, polluted. Their light carried the clear fingerprints of heavy elements sitting right at the surface, where nothing heavy should be able to linger. Calcium, iron, magnesium, the very stuff that rocky worlds are made of. There is really only one gentle way to explain it. That material must be arriving now, freshly, and constantly, raining down onto the dead star faster than it can sink. In other words, these white dwarfs are eating. Their old planets and asteroids, still orbiting after the star's death, are being pulled in, torn apart by the dead star's gravity, ground down into rubble and dust, and swallowed. Around some of them, telescopes can even see the ring of debris, the shredded remains of a world spread into a thin, bright disk, feeding slowly inward. The strange gift in this is that the destruction lets us read the recipe. When a white dwarf swallows a broken world, that world's chemistry shows up in the star's light. So by reading a dead star, astronomers can measure what its lost planets were made of. They find rock, much like our own. They find iron, like the core of the earth. In a few cases, they find signs of water, once locked in those far-off worlds. The eaten planets tell their ingredients one last time, written in the glow of the thing that ate them. It helps to picture how one of these embers is made. Near the end, a star like the sun swells enormous and red, then gently breathes its outer layers off into space, where they drift away for a while as a soft, glowing shell. What stays behind is only the bare, hot core, no longer burning, just cooling. The nearest one to us rides beside the brightest star in the whole night sky. It is the small white companion of Sirius, a full sun's worth of matter squeezed into a ball the size of the Earth, keeping pace with its dazzling neighbor, cooling quietly in all that glare. And a great many dead stars carry the same faint trace of metal, which tells us the swallowing of worlds is not some rare accident. It looks to be a common, ordinary ending for the planets of ordinary stars. Around a few of them, telescopes have even caught the ring of rubble mid-meal, a thin, bright disk of shattered world spiraling slowly inward. None of it is loud. A white dwarf makes no sound when it feeds. It simply glows on, a little steadier for the meal, holding the dust of its lost worlds close to its surface, where the light can still read their names. It sounds harsh, and in the plainest sense it is, but it is also slow and old and very far away, and it is the ordinary fate of ordinary planetary systems when their star grows old. Someday, in the far future, our own sun will become a white dwarf like these, small and white and cooling. Some of what it leaves behind may drift inward in just this way. That is real. It is also billions of years off, and there is nothing in it to carry into sleep tonight, except the quiet fact that even a dead star keeps a kind of memory, written in the dust of the worlds it once held. Some worlds are made almost entirely of metal. They are the bare hearts of planets, with the rest stripped away. Think back to Mercury and its enormous iron core wrapped in only a thin skin of rock. Now imagine a world that is nearly all core, an iron ball flying around its star with hardly any stone left on it at all. Astronomers have found worlds that seem to be exactly this. They are startlingly heavy for their size, far too dense to be ordinary rock, which means they must be mostly metal, straight through. The best guess for how a world ends up this way is not a gentle one, though it is very old and very finished. Long ago, such a planet may have been an ordinary rocky world, with a metal core and a thick coat of stone, much like the Earth. And then something enormous struck it, a collision with another young world, hard enough to blast the entire rocky outer layer off into space, leaving only the dense metal heart behind. What is left is the core, laid bare, still circling the star. a planet with its whole outside knocked away. A world like that would be a strange sight up close. Heavy, dark, metal underfoot in every direction, perhaps still scarred and half melted from the blow that stripped it. No air, no water, only the exposed iron heart of a world that used to be so much more. It is a hard story, but a quiet one now. Whatever violence made these worlds happened billions of years ago, and it is long over. Today they simply orbit, dense and dead and done, the surviving hearts of planets that came apart before anything alive could ever have known them. There is nothing left on them to break. The breaking already happened a very long time ago, and the dark metal has been coasting, calm and cold, ever since. Not every world has a star. Some drift through the galaxy entirely alone, with no sun to orbit, no day, no year, only the long dark between the stars. They are called rogue planets, and there may be more of them than there are stars in the whole Milky Way. That is a hard idea to hold, so it is worth going slowly. A rogue planet is a world without a sun. Some were probably born around a star and then thrown out, flung away by a near miss with a bigger planet, cut loose to wander. Others may have formed on their own, out in the cold, never bound to any star to begin with. Either way, they now move through the galaxy untethered, dark worlds crossing the dark, taking hundreds of thousands of years or more just to drift the distance between one star and the next. For a long time, no one could count them, because a world with no star gives off almost no light. But there is a clever way to catch them. When a rogue planet passes almost exactly in front of a distant star, its gravity bends and briefly brightens that star's light, like a lens drifting across a candle. The star swells in brightness for a few hours or days, then fades as the invisible world moves on. By watching millions of stars and waiting for those small, brief brightenings, astronomers have begun to take a census of the wanderers. The counts keep coming back high. Some careful estimates suggest rogue worlds outnumber the stars several times over, which would mean trillions of them, adrift and unseen, all through the galaxy. A telescope built for exactly this search is due to launch in the next few years, and it should turn that rough guess into something much closer to a real head count. Picture one of them, a world the size of the Earth, or larger, moving through space with no sun anywhere near. Its sky holds no daylight, ever. There is no sunrise to wait for, because there is no sun. Overhead, there are only the distant stars, cold and unmoving, and the faint band of the galaxy. The surface, if it is bare rock, would be colder than almost anywhere, hundreds of degrees below zero, frozen hard and still, in a night that has no morning coming. And yet here is a thought worth telling, purely for the pleasure of it, with no promise attached. A world does not only get warmth from a star, it can also hold heat inside itself, left over from its birth, or made deep down by the slow decay of the elements in its rock. On a large enough rogue planet, with a thick enough blanket of ice or air, that inner heat might be enough to keep a hidden ocean liquid deep beneath a frozen shell in total darkness, warmed from below instead of above. No one can say for certain if such a place is out there. It is only allowed by what we understand, no more than that. But it is a gentle thing to imagine, a dark sea kept just warm enough, under the ice, on a world with no sun at all, drifting quietly between the stars. Most of them probably began around a star, like ordinary planets, and were then thrown out. A young planetary system is a rough neighborhood, full of near misses, and a small world that swings too close to a giant one can be flung away for good, out past all the others and into the open dark. Our own solar system may have done this, long ago, casting off a world it started with. If so, it is out there even now, drifting alone and cold, a lost cousin of Earth that never got its place at the fire. The wanderers come in every size. Some are small and rocky. Some are giants, larger than Jupiter, cut loose and sailing the black. A giant might even carry moons along with it, and a moon squeezed and warmed by its planet's pull could, in theory, keep a little heat of its own, a faint hearth in the middle of nowhere. It is only a possibility, told for the pleasure of the thought, but it means the loneliest places in the galaxy are not quite promised to be lifeless, only very, very unlikely to be otherwise. There is no need to feel the cold of it too keenly. A rogue world is not suffering out there. It is only traveling, slowly, through the great quiet between the stars, on a road longer than any empire has ever lasted, in no danger and no hurry at all. Most rogue worlds are surely frozen and dead. That is the plain likelihood, but they are not frightening, out there in their long night. They are just alone, and calm, and unhurried, sailing the dark on journeys that outlast whole civilizations, going nowhere in particular, in no rush to arrive. There are, it seems, more of them than there are stars to see. The galaxy is fuller of quiet wanderers than of lamps. There are worlds so light that they should barely count as worlds at all. Astronomers sometimes call them the puffy planets, and they are among the gentlest strange things in the whole catalog. Picture a planet as wide as Jupiter, the largest world in our own solar system, and then imagine it weighing almost nothing for its size. That is what these are. Great swollen balls of gas, blown up to enormous width by the heat of a nearby star, yet holding so little material that their density drops to something absurd. A few of them are lighter, for their size, than cotton candy. If one could somehow be set in a vast enough bath of water, it would float. They are puffed up because they sit close to their stars, and the heat pours into their outer layers and swells them outward, the way warm air lifts and expands. So they grow huge and thin and soft-edged, more like a warm haze in the shape of a planet than a solid, weighty world. They are hard to picture as anything but delicate, though they are nothing of the kind up close, only vast and hot and hazy. And because they are so light and so loosely held, their stars pull the tops of them away with ease. Several of these puffy worlds trail long streamers of escaping gas, quietly leaking themselves into space. Some may slowly deflate over the ages, giving up their thin outer layers until only a smaller, denser core is left behind. They are among the most fragile-seeming worlds anyone has found, though fragile is the wrong word for something so enormous. No one could ever stand on such a place, because there is nowhere on it to stand, only deeper and warmer haze all the way down. They are not homes for anything, but they are a soft reminder of how many shapes a dead world can take. Not all of them are scorched rock or frozen stone. Some are only warm, enormous, half there puffs of gas, drifting around their stars, light as a held breath, slowly letting go. The nearest world of all is close enough to sit in our own small corner of the galaxy. It circles the closest star to the sun, and no one yet knows whether it is alive or dead. The star is Proxima Centauri, said Proxima, and it is the nearest star there is, a little over 4 light-years away. That sounds close, and by the scale of this tour it is. But it is worth being honest about the distance. 4 light-years is so far that the fastest machine humanity has ever launched would take tens of thousands of years to cross it. The nearest star to our own is still an ocean away. Proxima is not a bright star like the sun. It is a red dwarf, small and cool and dim, the most common kind of star in the galaxy. Around it moves a world called Proxima b, found in 2016, about the mass of the Earth, and it sits at just the right distance from its little star for the temperature to allow liquid water. That narrow, lucky band around a star, not too hot and not too cold, is the thing astronomers most look for. The nearest planet to our own solar system sits right inside it. For a moment, that sounds like the best news imaginable. But the little red star is not a gentle neighbor. Red dwarfs like Proxima are restless. They throw out sudden, violent flares, far larger in proportion than anything our steady sun produces, flooding their nearby worlds with bursts of radiation. Proxima b huddles so close to its star to stay warm enough for water that it takes the full force of those flares again and again. Over billions of years, that battering may have stripped away any atmosphere the world once had and scoured its surface with hard light. The planet is also probably tide-locked, holding one face to its star, with all the trouble that brings. So the nearest world is a genuine question mark, and an honest one. It might hold a thin atmosphere and sheltered water somewhere, in the twilight ring or under the ground. It might just as easily be a bare, scorched, airless rock, sterilized long ago. The measurements needed to tell the difference are right at the edge of what today's telescopes can do, even for a world this close. So the truthful answer, for now, is that we do not know. Not knowing is not the same as knowing it is dead. It only means the door is still open, on the nearest world of all. The star it circles is part of a small family, the 3 sons of the Alpha Centauri group, the nearest stars to our own. Proxima is the smallest and closest of the 3. To put its distance in something like human terms, the light leaving it tonight will take about 4 years to arrive. So the faint glimmer a telescope gathers from it now set out 4 years ago. It is the next lamp along the shore, and even the next lamp along the shore is a crossing no one has yet found any way to make. The trouble is the little star's temper. Every so often it flares, brightening in minutes and flinging out a burst of radiation far larger for its size than anything the steady sun would manage. A world huddled as close as Proxima b takes those bursts full in the face, over and over, across billions of years. There are gentle dreams of one day sending a swarm of featherweight probes to fly past and look, riding a beam of light, though even at a fair fraction of light speed, the trip would take decades. For now, the nearest world stays a rumor no one can quite confirm. It may not even be alone out there. There are hints of one or two more worlds around the same small star, farther out and colder. So the nearest system to ours might hold a little family of planets, most of them surely dead, one of them just possibly not. There is something quietly moving about that. Of all the worlds beyond the sun, the very nearest one is the one we cannot yet call. It hangs there, just over 4 light years off, around its small flaring star, keeping its own counsel. Maybe a dead rock, maybe, against the odds, something gentler. It will take better instruments and more patience to find out. For tonight, it is enough that the closest world to home is still a maybe, turning quietly around its little red star, holding its answer a while longer. There is one more system worth visiting before the tour turns home, because it holds the most worlds of all in the smallest space, and because it is where the search for a living world is happening right now. It is a little red star, about 40 light years away, called TRAPPIST-1, and it is circled by 7 worlds, every one of them close to the size of the Earth. 7 Earth-sized worlds around a single star is astonishing on its own, but the truly striking part is how tightly they are packed. All 7 orbit closer to their little star than Mercury orbits the Sun. The whole family of 7 would fit comfortably inside the orbit of our innermost planet. They are crowded in, near their small, cool star, circling in a matter of days. Because they are so close together, they hang large in one another's skies. Stand on one of these worlds, and the neighboring planets would not be distant points of light. They would be real disks, some larger than our full moon looks from Earth, moving through their phases, so near that a patient eye could watch them turn. It is a system where the other worlds are close enough to feel like company, a crowded little family of 7, gathered around one dim red hearth. Several of them sit in that same lucky band where liquid water is possible, which is why so many telescopes have turned to look. And this is where the honest, careful part of the story sits. The James Webb Space Telescope has now studied the innermost of the 7 closely. The innermost world appears largely airless. The second lacks a thick atmosphere, though a tenuous one has not been completely ruled out. The inner worlds examined so far appear harsh and likely lifeless. That is not the end of the search, though, and it matters to say why. The inner worlds being bare does not settle the outer ones. Farther out in the same system are worlds in the cooler, gentler part of that band, and those are much harder to read. Their answers are not in yet. The instruments are working at the very limit of what they can do, teasing at whether a small world 40 light years away holds any air at all. It is slow, delicate work, and the results arrive one careful measurement at a time. The little star was named for the telescope that first caught the worlds, a modest instrument that watched the star flicker as each planet crossed its face. The star itself is barely larger than Jupiter, so cool and so sparing with its fuel that it will keep shining for trillions of years, long after brighter stars like the Sun have burned down and gone dark. The seven worlds move in a kind of lockstep, their orbits tuned to simple rhythms, each one tugging gently on the next, so that their years fall into ratios as neat as a line of music. It is one of the tidiest little systems anyone has found anywhere. Some of the seven weigh less than they should for their size, which hints that a fair part of them may be water, held as ice or hidden deep. That is part of why the patient work goes on. Telescope time is being spent, carefully, on the outer worlds, the ones in the gentle middle band, to catch any thin breath of air they might still hold. The answers arrive in small pieces, and slowly, and nobody is hurrying, because the little star is going nowhere for a very long time. So TRAPPIST-1 is left, for now, as a system half-answered. The inner worlds examined so far appear largely airless, or without thick atmospheres, and likely lifeless. The outer ones are still open questions, still being gently examined, still allowed to surprise us. It is the closest thing we have to watching the search itself, live as it happens, one small world at a time. And there is no need to know the ending tonight. The seven worlds will keep circling their little red star, crowded and patient, whether or not anyone has finished reading them. And some worlds, it seems, may be nothing but ocean, no land at all, no shore anywhere, just water all the way around and far, far down. On Earth, the deepest sea is a few kilometers deep. On a true ocean world, the water might run tens or even hundreds of kilometers down, wrapping the whole planet in one endless, unbroken sea. There would be no continents to break it, no islands, no beach in any direction. A traveler could cross the entire world and never once find a place to land, because there is no land to find anywhere on it. Astronomers think these worlds should exist, and may even be common. Some planets seem to hold far more water than the Earth, enough to drown every feature of a surface completely. A few may be warmer, wrapped not in a liquid sea, but in a thick, heavy blanket of steam. And at the very bottom of the deepest ocean worlds, the pressure would grow so immense that the water itself would be squeezed into strange, dense ices, warm ices, forming a smooth floor no diver could ever reach. Whether anything could live in such an endless sea, no one knows. Many of these worlds would be too hot, or the ocean too deep and too strange, for life like ours. So most of them, too, are likely dead. But of all the dead worlds on the tour, these may be the easiest to rest beside. A single quiet ocean, wrapped around a whole planet, with no shore and no storm-battered coast, only water and more water, rolling in slow swells under a distant star, calm all the way down. The tour turns home now, to the one world in all of this that is not dead. After the acid cloud and the rust, The raining rock and the sideways glass, the corpse star and the wanderers. There is Earth, warm, wet, covered in the one thing every other world on this tour was missing. It is worth seeing, for a moment, just how narrow the difference is. Earth is not far from Venus and not far from Mars, and yet it landed in the gentle middle, where Venus cooked and Mars froze. Its magnetic field helped shield the upper atmosphere, while its stronger gravity, active geology, and long-term climate cycles also helped it retain stable conditions. It sits at the right distance for water to rest as a liquid in oceans for billions of years without boiling off or freezing hard. Every hard-won condition that all those other worlds missed, this one somehow holds all at once. That is the whole reason there is anyone here to notice. It will not hold them forever, and that is real, and it deserves one calm moment before the night ends. The sun is slowly growing brighter as it ages. Far in the future, perhaps 1 billion years from now, it may warm the earth past the point where the oceans can stay. And in about 5 billion years, the sun will swell into a red giant, the way sun-like stars do, and gently take the inner worlds back. One day, in that far-off time, Earth will join the tour. It will become another quiet world the sun once held. But that day is billions of years away, which is longer than there have been oceans here, longer almost than the Earth has existed at all. It is so distant, it barely counts as a tomorrow. Tonight, the sun is middle-aged and steady, exactly as it has been all your life. It's set on schedule this evening, and it will rise on schedule in the morning, over an ocean that is in no danger of boiling, on the one world in all of this that is still, right now, alive. It is worth naming what all had to go right. Earth kept a churning iron heart and a global magnetic field that helps shield its upper atmosphere. Its gravity, active geology, and long-term carbon cycle also helped it keep stable air and climate. It settled at the one distance where water can rest as a liquid. It has the steadying moon at its side, helping keep its tilt within a familiar range. Any one of these could have gone the other way, as it did on Venus or on Mars, and there would be no one here at all to notice the difference. And there is one more thing, stranger than all the rest. A great deal of what makes Earth livable was made by the living things themselves. The very oxygen in the air was breathed out across billions of years by countless small lives in the sea. The living world and its life slowly built each other, together, seen from far enough away, from out past every dead world of this tour. The whole of it would shrink to a single soft blue point, no bigger than any of the others, and it would be the only one, so far as anyone has ever found, with anything at all awake upon it. None of it was ever promised. Run the whole story again, and 100 small things could tip the other way. A little nearer the sun, and the oceans might have steamed off into the sky, the way Venus lost hers. A little smaller, with weaker gravity and a faster cooling interior, and a stable atmosphere, might have been much harder to retain, as it was on Mars. The living world rests in a narrow band of luck, held mild by a dozen quiet balances. not one of which it ever had to earn. That is not a thing to worry over. It is only a thing to be quietly glad of. On a night like this, with the air still here and the oceans still full, that is the quiet marvel to rest on. Not that Earth will someday change, far away in deep time, but that tonight, and for an unimaginable stretch of nights to come, it simply is what it is, awake, watered, wrapped in air, the single warm exception in a long tour of the dead. So here is where the night has been. It went next door to Venus and stood on the hot orange plain under the ember sky, in the heat that melts lead. It crossed to Mars and followed the dry rivers of a world whose air blew away. It looked in on Mercury, keeping its fire and its ice in separate corners, and on the moon, holding its old footprints in the silence. It went out past the sun's family to the lava worlds, where models predict a cycle of rock vapor and mineral fall, and to the blue world where possible silicate grains are swept sideways in the wind. It walked the cold methane shore of Titan, the one dead world that still keeps its weather, and looked in on a planet hotter than a star, and another where iron may condense in the cooler air. It stood on the ring of endless dusk, on a world that cannot turn. It watched a planet being slowly, gently eaten, 3 million years from its ending. It saw a small world crumble into a long tail of dust, and a cold giant turn under 2 setting suns. It found the first 3 worlds we ever saw, circling a dead star in Virgo. It met the oldest planet of all, older than nearly everything there is. It read the dust of swallowed planets in the light of white dwarfs, and drifted with the sunless wanderers, more of them than there are stars. It drifted over worlds drowned in a single endless sea. It paused at the nearest world of all, still holding its answer, and at the 7 crowded worlds around their little red star. And it came home to the only warm one. Here is the thing worth carrying down into sleep. Most worlds are dead, and that is not a sad thing. A dead world is simply what matter does when it is left alone, the plain and ordinary state of nearly everything. A living world is the rare exception, the one narrow accident of warmth and water and shelter that everything soft depends on, and that is exactly why it is worth all this wonder. The dead worlds are not a tragedy. They are the still, dark background that makes the one lit window astonishing. And all of it is still out there tonight, turning without any need to be watched. Venus keeps its heat. On the lava worlds, mottled rock vapor cycles continue on far molten shores. The wanderers keep crossing the dark. The dead stars keep their quiet memory of the worlds they held. None of it is in any hurry, and none of it is coming here, and none of it asks anything at all of the one warm world where a person is lying down to rest. None of these worlds is a warning, and none of them is a sorrow. They are only the plain, quiet company of the one that is not dead. Venus and its held heat, Mars and its dry rivers, the mottled rock vapor weather, and the possible silicate storms, the sunless wanderers, and the 7 small worlds around their patient star, all of them turning, all of them far, all of them perfectly fine, exactly as they are, It is a wide and gentle dark out there, and it only makes the small, warm room feel softer. So let them be, the dead worlds, out in their patient dark. There is no need to hold a single one of them in mind. They asked for nothing when no one was watching. Across all the ages, before anyone was here to look, and they ask for nothing now. They will keep. There is nothing left to do now but rest. The dead worlds will keep, exactly as they are, patient and far away, all through the night and long after. The only living world anyone has ever found is turning softly underneath, holding its air close, keeping the dark and the cold a comfortable distance off. Stay warm. Stay where it is soft. There is nowhere else to be tonight, and nothing to reach. Let the far worlds turn without you. Good night.